previous video I said that as per the academic session of 2021-22 there is a slight change in the CBSE syllabus of mathematics class 10, where only the proof of 2 theorems have to be learned but not all the 5 theorems. So in previous video I have already explained about basic proportionality theorem, and here I am going to explain you Pythagoras theorem. So let's start with its statement. Its statement states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So here you can see that it is a right triangle, right angled at B, and the side opposite to the right angle is called hypotenuse. So AC is the hypotenuse and the other two sides are AB and BC. So first we will write the thing which is given to us. Here we are given that angle B is 90 degree. Angle B is 90 degree in triangle ABC. Next thing, what is to be proved? We have to prove that sum of the squares of the other two sides is equal to the square of the hypotenuse. So here the hypotenuse is AC. So square of the hypotenuse that is AC square is equal to sum of the square of the other two sides. The other two sides are AB and BC. So it will be AB square plus BC square. And as we know, for proving any theorem we need to do some construction. So here what we have done is we have constructed BD perpendicular to AC. So let's write that also, BD perpendicular to AC. Now let's start proving it. And for its proof we will be using one of the theorem given in textbook, which states that in a right triangle, if a perpendicular falls from the right angle, then the triangles which it divides are similar to each other, and the bigger triangle is also similar to them. I repeat, in a right angled triangle, a perpendicular falling from the right angle divides the triangle in two triangles, where the two triangles will be similar to each other and each triangle are similar to the original triangle as well. So that property we will be using here, and this theorem is given just before Pythagoras theorem in NCERT, and that will be used over here. So let's start proving it. So using the theorem which states that a perpendicular falling from the right angle, as we can see here, a perpendicular, this is perpendicular, which is falling from the right angle of a right triangle, divides the triangle in two similar triangles. That means triangle ADB is similar to triangle BDC, and the triangle itself is similar to them. That means this ABC is also similar to these two smaller triangles. So using this we can write triangle ADB is similar to triangle ABC. Triangle ADB is similar to triangle ABC. So once they are similar, we know once the two triangles are similar, by basic proportionality theorem their corresponding sides are in same ratio. So we can write AD by AB is equal to AB by AC. This we can write, isn't it? And from here if we cross multiply, we get AD into AC is equal to AB square, and let us say this is equation 1. Similarly we can also write triangle BDC is similar to triangle ABC. Triangle BDC is similar to triangle ABC, and by basic proportionality theorem we can write CD by BC, because once we are showing two triangles are similar, they are written in a very systematic manner, that order has to be followed. So if I'm taking CD side of triangle BDC, I have to take the corresponding side BC, which is of triangle ABC. So like that we are considering the ratios. So CD upon BC will be equal to BC upon AC. Now again let's cross multiply, which gives CD into AC is equal to BC square, and let's say this is equation 2. Now from both the equations, from 1 and 2, we can write what we are doing actually with 1 and 2. Our statement of which was to be proved was AC square. This was to be proved. We had to prove AC square is equal to AB square plus BC square. This was our target. So here we can see AB square is on right hand side and BC square is on right hand side, which are to be added. So that gives us hint of adding the both equations. So from 1 and 2, what we are doing, we are adding them. We are adding equation 1 and 2, and we get AD into AC. Left hand side will also get added. CD into AC is equal to AB square plus BC square. Here we can see AC can be taken outside. So AC is taken outside. Then we are left with the AD plus CD is equal to AB square plus BC square. And now here when we check this AD and CD in the figure, AD plus CD is nothing but AC. So let's replace this whole sum by AC. So AC into AC is equal to AB square plus BC square, and this gives us the desired result, which is AC square, that is square of the hypotenuse, is equal to sum of the square of the other two sides, and hence is the result. Thank you.